questions?
Hypothetically, this question could show up on a test.
Yeah.
Right, this would be like a pretty standard problem that'd be on a test, right?
It would be one of the more complicated problems on a test.
I thought it was only getting worse for me.
No, I wasn't gonna go worse than this. When you do the master set for chapter 23, it all comes with it.
You mean 24?
Yeah, that too. 24.
How many chapters usually cover one test?
First test will be 4 chapters.
So the average, that's 3 to 4?
First test is usually, I think, 4 chapters. Second test is 3 chapters. Third test is 20. However many chapters, whatever we get to.
20 chapters?
Third test will be magnetism, relativity, magnetism/electromagnetism, relativity. I can't remember how many. I think that's 5 chapters.
Special relativity?
Do it again?
Special relativity?
Yes, not general relativity.
What's the difference?
Oh, I remember the last question on our test, 152. It was a relative, special relativity question.
Special relativity assumes a reference frame which is not accelerating. General relativity does not make that assumption.
What do you mean not accelerating?
We assume things are traveling in a straight line at a constant speed. We're not worried about objects that are speeding up or slowing down relative to some source or accelerating references. That's what I mean.
Okay. Because it gets way more complicated.
Yeah, considerably more. Yeah, calculus doesn't quite cover it at that point. Then you start getting into tensor calculus. So vectors are to scalars like tensors are to vectors.
Yeah. Tensor?
Tensor. It's like a 3-dimensional. It's a vector that
We scaled 3-dimensionally.
and I was wondering if I could get away with 9-dimensional vector, but that doesn't quite cover it. It's just it just takes a whole lot more stuff into account.
Okay.
So like, general relativity is dealing with like large gravitational fields and stuff, or like black holes, because it causes things to accelerate.
Yeah, it warps space itself. The basic concept of general relativity I can handle, but once you get past that, my mind blows.
The 3 times 10 to the negative 9th or 4, is that the constant value for lambda
In this problem.
in this problem?
You just make it up, or?
Yeah, this number I just said, I just gave it a 3 nanocoulomb charge
Oh,
and
that's
said it
what
was
it
4
is.
meters
Well,
long.
Is it 3 to the negative 9? Is that always the same? Times 10 to the negative 9?
Nano is always times 10 to the negative 9.
And the 3, the 3 and then 4 you made up.
Yeah. Nate, did I answer your question?
Yes. But lambda can always change depending on the problem.
Yeah, oh yeah, oh yeah.
Yeah.
In the problem I did yesterday, I went ahead and told you what lambda was. In this case, I didn't tell you lambda, I said it was a uniform charge distribution. I gave you the total charge and the total length, and you calculated from there.
Are we gonna learn on uniform charge distribution?
I haven't in the past. I've played around with it, and not yet. But if I change my mind, hopefully I will let you know before the test.
I recommend you don't change your mind.
I will take that under advisement. So what I'm gonna do is, today is the 23rd. Oh, I got the master's at 23 to, what that is?
Yeah.
It's the 23rd, okay. We'll say master set 24 is due February 4th. And we'll put that homework quiz for 24 on the 6th.
Don't we have that homework quiz before the master set is due?
You wanna do it the other way around?
Yeah, probably, yeah, because we've already been talking about electric fields, that seems better.
Alright.
Cause it's just 2 or 3 problems for the quiz, right?
It'll be the flash information plus 2 problems.
That's not what I was.
So this is
talking
it
about.
for,
Okay.
Oh, you don't want it this way?
No, I was confused why a quiz would be before the homework is due, that was my question.
No, it's no skin off my nose whether you do the textbook quiz, flash/textbook quiz first, and then have the master set due, or other way around.
I don't know, it just seems this way, because
In
you
my
have the
experience.
master set due on Thursday, and then we have a lab, and then the next class we have another master set due, so this seems better.
Okay.
Well, I don't know, maybe I'm wrong though.
in my experience, I've always had an easier time with the quizzes than I have with the master sets. Having more time with that. Because quizzes are literally the textbook homework problems, it's copy paste on it's
And
different numbers.
change the numbers.
And change the numbers, yes. But the setup is all you need to study. The rest
From
of
the
it's-
master set?
No, from the textbook homework.
Oh, the
problems.
types of problems, yeah.
Because the solution's there. It's literally just like.
So this way gives us time to look at the textbook homework problems over the weekend.
Yeah.
I think so, and then still have time to do the master set even after the quiz.
What I moved is I put the homework quiz first on the 4th, and then the master set due on the 6th,
That's for chapter 24.
for chapter 24. For chapter 23, that was written up.
All
on
the
Tuesday.
same?
The homework quiz for chapter 23 is next Tuesday.
Yeah, and then Thursday is the master's day.
Yeah.
Where do you guys might have just talked about this, but you only posted the solutions, where do you see the problems?
In the textbook.
Where do you access that, like the hard book ones?
Yeah.
We could only get in class. Is there like an online version of it or no?
I don't know.
Okay,
There
What?
should be.
like the homework questions?
You
Only
remember I showed you where they were?
Is that on my tab, you can see it on there too?
Oh, yeah, I think so,
Like
yeah.
the answer
It's all the
is-
same,
Okay.
it's like the MyTab version is the same as the.
I saw the solutions, I just didn't see the question itself, you know what I mean?
Pretty sure it has the questions too. I have to look at it again.
I can't read them right. No, 151 and 152, the question is included. What I get from the publisher is what I basically cut and paste into the solutions document. 151 and 152, the question's included, so in their solution, they have the question, they have the solution. 110, I think, is just the answer, it's not the question itself. And 251, 252, I don't remember.
Okay, I'll have to look at it now.
I often wondered though, if given the solution, could you figure out what the problem is?
Can we do more calculus?
We are going to do something to avoid some calculus.
Oh.
I'm gonna start out with a point charge. And I'm cleverly gonna give it a label of Q. What do you know about the electric field coming from that point charge?
Is it positive or negative?
Assume positive,
It's going away from it.
okay? Electric field going away. What else do you know?
Gonna be uniform, since it's a point charge.
Say it
It'll
again?
be uniform since it's a point.
when you say uniform, it doesn't matter where I am in space other than at the point charge itself, that it have the same value. The electric field is not uniform,
Oh.
unless you wanna throw in some extra qualifiers.
Not what I was talking about. I don't know what you mean. Yeah.
Man, I'm really looking forward to getting the hearing aids, but until then,
No matter which like around it, it will be the same. But as you go out, it's going to get less.
so as long as I'm the same distance from the charge?
Same distance from the charge, yes.
Alright, so the same distance from the charge, all the same magnitude of electric
Yeah.
field. Direction is still gonna be different. But what is the magnitude of the electric field?
The Coulomb's constant time at the point of charge.
And for this one, I am gonna put the other form of it, 1/4 pi epsilon, so not,
Times the charge over the distance squared.
the magnitude, I asked for the magnitude, I'm throwing it in the vector form. Alright,
Mind tap.
need you to flash back to dot products. I think that was a sound of joy escaping.
Products aren't hard.
We're learning in calculus 3 right now, again.
Alright, if I take let's do paper. I got a piece of paper here. What is the direction of the area vector of this side of the piece of paper?
Direction.
The direction of the area vector, we'll do it this way. What is the direction of the area vector of this piece of paper?
Outside the wall,
Like, you pointed in the right direction, I missed the words.
pointing out of the page.
Pointing out the page, alright. If it were one-dimensional, I mean, it is two-dimensional in reality, but if it were a one-dimensional surface, what are the two answers that you could use?
Right order, right?
Yeah, it's either that way or that way. If I've got a one-dimensional a two-dimensional surface, not an inside or outside, there's just like a plane, then the direction of the area vector is it's perpendicular, pointing either side. But if it is a closed system, in other words, I can't get from one side to the other of the surface without going through the surface, so it's a closed figure, then it's pointing outwards. Direction of the area vector by the powers that be, say area vector pointing outwards.
Why is it called an area vector?
The area vector, because if I have a sheet here, let's set up a coordinate system, I hat, J hat, K hat, and I have a 2 meter by 3 meter. I know the area is 6 square meters, but I have to somehow indicate the orientation of this rectangle
Oh, okay, in
And-
3-dimensional space.
in 3-dimensional space, yeah. I mean, you could, I guess, say, well, you drew it on the board is vertical relative to the ground, but math people want to say in as few character strokes as possible. So, 6 square meters, K hat. Or negative 6 square meters, K hat, if you want to go the other direction, if this is just the 2-dimensional. But if it's 3-dimensional, and it is a closed surface, the area vector points outwards. You don't really have a choice. So if I take a sphere, the area vector at this point is that way. The area vector at this point is that way. The area vector right here is pointing that way. It's always out away from the surface. So what I want to do here is I want to imagine that I have a surface here. It's not a real one, I'm just imagining that I have a sphere. Imagine sphere. So I know the area vector at any point is going away from the center. Let me say imagine sphere with center at Q. So the charge is at the center of the sphere. The area vector is going out, so at any point on the surface, my electric field and my area vector will be in the same direction. As electric field points away from the center, from the charge, which is at the center, area vector points away from the center. So what is the dot product between the electric field and the area vector?
Can you restate the question?
I'm trying to do a dot product. I got at any point on this surface here, the area vector and the electric field are pointing in the same direction. You want to be pedantic about it. This is a very small bit of surface here, so dA, dE. Technically, they're differentials. But what is the dot product between these two vectors?
One? No. Because they're going in the same direction. Wait, no, right.
How do you find dot products?
You have a vector, and you times the first two, and then minus the other two, or add the other two times.
Okay, I was thinking from comments earlier that the memory was better on that one. Sorry, that was not, it came across like a criticism. There was always that, starting every semester, the second semester, of course, where people remember the dot products from the first semester. I just went through this in 152. They remembered it had something to do with vectors. Especially since I said we're multiplying vectors with a dot product. All right, how about, what is the difference between a dot product and a cross product?
Dot products result in scalars.
Okay.
Cross products result in vectors.
Or if you want to be picky,
Matrices.
it's actually not a vector. It's called a vector product, yes, I agree with that. And it looks, smells, and tastes exactly like a vector from anything that we're gonna do in this course. However, if you really wanna be picky, a cross product doesn't give us a vector, but
A vector product.
and I'm thinking of, Adrian, you've heard this, I know.
Say the question one more time.
If I do a cross product between two vectors, as far as we're concerned, it looks and tastes and smells like a vector. The answer is a vector. That's fine. However, officially, it doesn't produce a vector. I'm assuming it's not coming to you.
Yeah, nah.
It produces what's known as a pseudo vector or an axial vector.
Now we can.
Yeah. So that's just more trivia at this point. Later on, if you get into more advanced physics, eventually the distinction will come in. In terms of my thesis and my dissertation, I never had to worry about that, but the theorists do. All right, so dot product, cross product. This is a vector product. And I'll parenthetically write axial or pseudo. I think it tends to be called an axial vector now. A pseudo vector is the older term for it. Dot product produces a scalar. All right. What else is the difference?
Dot products you times and then add. Cross products, it's matrices.
Yeah, but you're still gonna multiply and add.
It's a different kind of
cross
multiplying and
products.
adding.
Care about the,
Cross products or orthogonal.
All right. Cross product cares about perpendicular. Or let's just start with the symbol. The symbol for a cross product is the x. This symbol for that is a dot. This, think about the perpendicular to each other. This cares about, this multiplies perpendicular parts, this multiplies parallel parts. So if I have a vector A, a vector B, some angle theta, Well, I can break A up into its components. I know part of A is in the direction of B, part of A is perpendicular to B. So if I broke A up into a component going this way and that way, so that's a right angle, and that is supposed to be straight. Then this component down here is A cosine theta. This part right here is A sine theta. And so A dot B is just going to be A cosine theta times B. Or A B cosine theta. If instead of breaking A up into components, I broke B up into components, so I got my A here and my B. If I broke B into its components, I got part going along A, part perpendicular to A, that angle's still theta, so that's B sine theta, B cosine theta. And so I multiply parallel parts, I get B cosine theta times A, which is just AB cosine theta.
There's also a way if there's not an angle where you can just add, right? You add the product.
As in, if I give it to you in rectangular form.
Yeah.
So if we have one I hat plus two j hat dot product, 3 I hat minus 4 j hat. I think this is what you were talking about, Paul. You multiply the I hats together, you get 3, plus you multiply the j hats together, -8, you get -5. You multiply the parallel parts and then add. If you give it to in polar form, it's a little bit simpler, as long as you have a calculator. Unless the angle is one of the nice angles where we know the cosine. So, back over there, if my area vector and my electric field vector are in the same direction, what would be the dot product?
0.
If they're in the same direction,